start today by refreshing our knowledge of the primary trig ratios. So for an angle in standard position, we have three primary ratios: sine, cosine, and tangent. And we write formulas for them in terms of x, y, and r. This allows us to have negative values for x and y when we draw this angle on a coordinate plane. Our formulas that we used in pre-cal 11, sine theta is equal to y over r, cosine theta equals x over r, and tan theta equals y over x. For the unit circle, we have a radius of 1, and this allows us to rewrite our equation slightly when we're looking for a point that is on the unit circle and on the terminal arm of the angle. So if we have the angle theta, we can say that sine theta is equal to y over r, but now our r value is 1, so it's y over 1, or just y. Oops, turn that off. For cosine theta, it is x over r, or x over 1, so cosine theta is actually just equal to x. And tan theta is still y over x, but now we can say that y is equal to sine theta, and we can say that x is equal to cosine theta. So this also gives us a relationship between tan theta, which is that it's sine theta over cosine theta. So if we are given an angle and we are looking for a point specifically on the unit circle, we can say that the coordinate x comma y is actually cosine theta comma sine theta. So now given an angle, without knowing x or y, we can find both x and y using theta for the point on the unit circle. So let's take a look at an example. We have an angle in radians. Theta is equal to 1.28. Let's find the coordinates of a point P that lies on the intersection of the terminal arm of theta and the unit circle. Let's start with figuring out where this angle would be. Now, if this is 0, this is pi over 2, which is approximately 1.57. So theta is going to be a little bit closer up top. Maybe this is our terminal arm. And we don't know x or y, but we do know the radius is 1. We can now use the fact that x is equal to cosine theta. So x is equal to cosine 1.28. And calculating that in our calculator in radian mode, x is equal to 0.287. We can do something similar to find our y value. Y is equal to sine theta. Y is equal to sine 1.28. And calculating that out, y is equal to 0.958. This gives us the point P, which is 0.287, comma 0.958. Mind you, this is only accurate to the nearest thousandth because we did do a little bit of rounding, but that's our new point P. Pretty straightforward? Yeah, so it's a very useful relationship. Now, before we examine too many more of these, we also want to introduce the reciprocal trig ratios. When we talk about a reciprocal, we mean 1 divided by something. So when we say the reciprocal of sine theta, it would be 1 divided by sine theta. Sine theta, we remember, is y over r. The reciprocal is r over y. The name of that reciprocal trig ratio is cosecant. Now the idea is if you know sine theta, you can calculate 1 divided by sine theta to get cosecant. Or if you need to find cosecant, you can simply do r divided by y. We have similar reciprocal ratios. Secant is the reciprocal of cosine theta. It's r over x. And cotangent is the reciprocal of tangent. It's x over y. So notice that we use the same letters x, y, and r. However, each individual ratio is simply the reciprocal of the other trig ratio. We may sometimes be asked to find these ratios Or we may be given one of these ratios, in which case it's pretty easy to translate it into a primary trig ratio instead before we work with it. Let's take a look at an example where we have to find some trig ratios. So in this example, example 2, we are given a point. The point A is 5 over 13, comma, negative 12 over 13. It lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. So let's figure out approximately where A would be. We have a positive x value and a negative y value, and let's zoom in a little bit to draw this. Looks like it'll be something down here, so let's draw in our terminal arm, and then we'll dash in an x and a y. So x is 5 over 13, y is negative 12 over 13. And knowing that this is on the unit circle, we already know that r is equal to 1. If we didn't know that the point was on the unit circle, we could calculate using x and y. So we have x equals 5 over 13, y equals negative 12 over 13, r equals 1, which is why we love the unit circle, just for the convenience of that. And for this, what we're going to do is find the values of all 6 trig ratios. So let's start with our primary trig ratio, and then we'll find the corresponding reciprocal. So for sine theta equals y, actually, because we're on the unit circle. So it's just going to be negative 12 over 13. Cosecant is equal to 1 over sine. So we take the reciprocal. This would be negative 13 over 12. So the reciprocal trig ratio is not actually too bad to find. Let's find our other ratios. So cosine is normally equal to x over r, but we're on the unit circle, so it's actually just equal to x. It's equal to 5 over 13. The reciprocal identity secant, that's 1 over cosine, is the reciprocal of 5 over 13, so that's just 13 over 5. Okay, and last one does require a little bit of calculating. Let's fit it in down here. Tan theta is equal to y over x. I'm going to do a fraction and a fraction, forgive me. So our y value is negative 12 over 13 divided by 5 over 13 for our x value. Negative 12 over 13 divided by 5 over 13 is going to be negative 12 over 5. So that is our reduced ratio for that one. And notice how I just leave it as an improper. That's going to make it a lot easier when I find my reciprocal. So cotangent, x over y. You could recalculate it, or you could use the fact that you already have your tangent ratio, and you can just take the reciprocal, and it will be negative 5 over 12. So for one angle, we should be able to find all 6 trig ratios using x, y, and r, especially easy on the unit circle where your r value is 1. All right. A little point of fact, you may notice as we went through these, some of our ratios had a positive value and some had a negative value, depending on x and y. In our case, we were in quadrant 4. X was positive, y was negative. So some of our ratios ended up being negative. We did have a memory trick for this. So there's a little diagram here that kind of breaks out the 4 options for you. But what we use is ASTC to remind us what is positive in each quadrant. So in quadrant 1, A stands for all ratios are positive. And we do ASTC. All students take calculus if you like that. We know that sine is positive in quadrant 2. Tangent, I'm not going to be able to fit it in, we'll squish. And cosine. Now, if we need to know signs for our reciprocal ratios, keep in mind that when you take a reciprocal, you're not actually changing whether it's positive or negative. So if sine is positive in quadrant 2, so is cosecant. If tan is positive in quadrant 3, so is cotan. If cosine is positive, so is secant. And we notice that here in this example we just did. For example, we had a value of cosine that was positive. Our reciprocal is still positive. Sine was negative, cosecant is also negative. Now, most of the time, if you are setting this up with a point and your x and y values have positive and negative signs on them, you don't necessarily need to use the ASTC, but it is a good way of checking your sign or just giving you a quick reminder of what to expect in each quadrant. All right, before we go on to finding some more trig ratios using exact values, let's just do a little refresher of our special triangles. And let's practice doing them with our angles in radians this time. So one of our special triangles is the 45-degree angle triangle in radians. That is pi over 4, and 90. And our sides are 1, 1, root 2. That's kind of our default. If we were on the unit circle and we wanted a smaller one, we could divide by root 2, divide by root 2, divide by root 2, so that our hypotenuse or radius is equal to 1. But in general, kind of like as a default, I usually just stick with the original triangle, and we can reduce as needed. So that takes care of pi over 4. Our other triangle is the one with the 30-degree angle and the 60-degree angle. So our 30-degree angle is pi over 6. Our 60-degree angle is pi over 3. And this triangle is 1 root 3, 2. Smallest side across from the smallest angle, biggest side across from the biggest angle. So 1 root 3, 2. This gives us an easy way of finding our basic trig ratios and I guess our reciprocals for 3 angles very easily. Let's just quickly find those actually. So if we start with pi over 4, what is sine pi over 4 equal to? So if we use pi over 4 as our reference angle, we're doing y over r, or our opposite over our hypotenuse, and it's going to be 1 over root 2. You can rationalize and make it root 2 over 2. Cosine pi over 4 if you're asked to find it. Also 1 over root 2, or root 2 over 2. Tan pi over 4 is 1 over 1, or just 1. This also allows you to find an exact value for the reciprocal trig ratios. Just take the appropriate ratio and find the reciprocal. We can do the same thing for our other angles. So let's go ahead and do this for pi over 3 and pi over 6. If you'd like to pause the video and try it yourself, you could do that. I'll start with pi over 6. Sine pi over 6. So pi over 6 is our reference angle. So in this case, this is our opposite. This is our adjacent. This is our hypotenuse. So this one is going to be 1 over 2. Cosine pi over 6. Root 3 over 2. And tan pi over 6. 1 over root 3, or root 3 over 3. Okay, let's do the same thing, but this time let's use the pi over 3. So now this is our opposite, this is our adjacent, and we can find all 3 trig ratios for this as well. Sine pi over 3 equals root 3 over 2. Cosine 1 over 2, and tangent root 3 over 1, or just root 3. So that gives us many angles that we can find our exact value for. The other ones that we could also find an exact value for are anything that is a multiple of 0 or 2 pi, just by using our quadrantal angles. So for example, if this is 0 and 2 pi, this is pi, this is pi over 2, this is 3 pi over 2. If we think about points on the unit circle, for an angle of 0 radians, we have a point 1, 0. That gives you an x value and a y value. We have a point 0, 1, negative 1, 0. and a point 0, -1. So picking one of those 4 points, depending on your reference angle, will give you an x value and a y value, and because we're on the unit circle, your r will still be equal to 1. We'll look at some examples of that down below. But basically, these are the ratios that you want to be able to find. You don't necessarily have to memorize every single ratio, but you want to be able to sketch either the triangle or your angles on the x and y axis to find an x value and a y value and then find that ratio. And then you can decide based on the quadrant whether it will be positive or negative. Okay, let's look at some examples of that in practice. So we will find the exact value of each trig ratio, and even if it doesn't specify, I find it very helpful to quickly sketch an angle just so we know where that angle is. So 4 pi over 3, we have pi over here. 4 pi over 3 is an extra 1/3. It's going to be here. I'm going to sketch in a triangle. So this is my actual angle, 4 pi over 3. But my reference angle is just going to be pi over 3. That's enough for me to quickly label in some side lengths, -1, -√3, and 2. So notice I'm not worrying about the unit circle. I'm just using the special triangle as a reference to get my ratio of sides. So sine 4 pi over 3 is going to be equal to y over r. And I do need that r value because it's not on the unit circle. It's going to be -√3 over +2. And that's actually our answer. So you could straight up write sine 4 pi over 3 equals -√3 over 2. If we do a quick sign check, we are in quadrant 3 where we would expect sine to be negative, and that is indeed the case because our y value is negative. That's pretty much all we have to do. Let's look at a few more examples of this and see how they go. If you're feeling pretty confident, you could pause and try them yourself and then come ahead and check the answers. All right, next angle, let's take a negative angle, -5 pi over 4. So negative pi would be up to here, and then a bit more than that. This will be -5 pi over 4. We sketch in our triangle. Our reference angle, I'll write in theta r, is pi over 4. So this is going to be a 1, 1, √2 triangle. Notice that our x is negative. So it's -1 for x, +1 for y, positive √2 for r, because r is always positive. Cosine, -5 pi over 4 is equal to -1 over √2. Or if you'd like to, let's build those good habits, -√2 over 2. If you are asked to show how to do this without using a calculator, or if you're asked to find an exact value, the expectation is that you are drawing some sort of sketch or diagram to show where are your x and y values coming from. It doesn't have to be a very fancy diagram, but you want to show something to show where did you get your x, y, r values from. All right, let's do a couple more. Tangent 5 pi over 6. Sounds like this one's also going to be in quadrant 2, but different reference angle this time. So 5 pi over 6 is less than pi, so it'll be up here. Our reference angle, theta r, is just pi over 6. So we want our 1√3, 2 triangle. We have the smallest angle, so smallest side is going to be 1. We have a -√3 and a +2. So again, if you're wondering about the signs on the x and the y, just look at where it is on the coordinate plane. In quadrant 2, your x value is negative going to the left, but your y value is positive going up. You just need to decide those signs based on the quadrant you're in. Then tangent is equal to y over x. So in our case, that's going to be 1 over -√3, and rationalizing -√3 over 3. Quick check for the sign. We're in quadrant 2. Tan should be negative. All is as expected. Okay, Let's try one where we have to do this using a reciprocal trig ratio. And let's think about what this means again. So if we have cosecant, that is the reciprocal of sine. So if we could find sine theta, then we could then find 1 over sine theta. Take the reciprocal, and that will be equal to cosecant theta. So when you're doing a reciprocal trig ratio, start with the original primary trig ratio, figure out what is it equal to, and then you can take the reciprocal. So let's just sketch this. 7 pi over 4, almost 2 pi, but not quite. So that's going to be halfway in between here in quadrant 4. There's our angle. Our reference angle is pi over 4. So we're going to put in our sides of the triangle. It's 1, 1, but negative y value, so negative 1 root 2. And then let's actually just start with finding sine of 7 pi over 4. So notice I'm not taking a reciprocal of the angle or anything like that. I'm just going to find the sine ratio. And when I find the ratio, I can take a reciprocal of the ratio. So this is going to be negative 1 over root 2. If it was my final answer, I would rationalize it. But if we're going to find cosecant, we're going to be taking the reciprocal right now. So let's do that first. So when we take the reciprocal, this is now going to be equal to negative root 2 over 1, or just negative root 2. Okay. The other way to think about this is originally we found y over r, and then we took the reciprocal to get r over y. If you're comfortable with it, you could draw your diagram and then straight up write your ratio for cosecant with r over y. But I find it easier to kind of find the familiar ratio first and then just take the reciprocal afterwards because it's not too hard to do that. Let's do another reciprocal just to make sure we've got that down. So cotangent. Negative 17 pi over 6 is not quite negative 3 pi. So it's a full negative 2 pi and then another negative 5/6 of pi. So one full rotation clockwise and keep going up to there. And make our triangle. Reference angle is pi over 6. So this is going to be 1, root 3, 2. This is negative. This is also negative. So let's start just by finding tan, and I do try to make a point of wrapping in brackets when we have a negative, just so it's clear that we're using a negative angle there and not subtracting. So tan is going to be y over x, or 1 over root 3. It's technically negative 1 over negative root 3, but that's going to be equal to 1 over root 3. Tan is positive in quadrant 3. And then we find cotangent, and for cotangent, we just take the reciprocal. So cotangent of negative 17 pi over 6 is just going to be the reciprocal of the answer we had before, and it will be root 3 over 1, or root 3. To kind of wrap this up, let's take a look at one quadrantal angle. So let's take an angle that is a multiple of pi over 2, noticing that that is going to be somewhere on the y-axis. So we have 0, 1 full rotation, this is 2 pi, this is pi over 2. So if we do 1 full rotation and then we keep going up to the positive y-axis, that is 5 pi over 2, so our terminal arm is actually here. And this might be a case for putting an arrow on your terminal arm just so you can actually see it. We take a point on the unit circle on this axis. Technically any point, but unit circle, very convenient. So this point here will be 0, 1. So x is equal to 0, y equals 1, r equals 1. When we find tangent of 5 pi over 2, it's going to be equal to y over x. And we just put in our x and y values. So tangent of 5 pi over 2 is equal to 1 divided by 0. We would say this one is undefined. But basically, using that 1 point to identify x, y, and r will allow us to find all 6 trig ratios for the angle 5 pi over 2. You can do similar things for any angles that are a multiple of pi over 2. Now, all of those are really great examples of how to find a trig ratio without a calculator using our knowledge of special triangles and some special points on the unit circle. If we do not have something like that and we have a different angle, we can still use our calculators. We're just going to put our calculators in radian mode to calculate. So this is where you want the mode on your calculator that says capital RAD. Usually there is some sort of button on your calculator that will say something like DRG, and tapping that button will allow you to switch. So if you haven't already put your calculator in radian mode, this would be a good time to do it. And we'll just practice calculating a few in the calculator. We're going to look at the reciprocal functions, but essentially your calculator will calculate the original function and then you find the reciprocal. So when we are finding secant of 1, we're actually finding 1 over the reciprocal function, 1 over cosine 1. So we're just going to calculate 1 divided by cosine 1 in radians. Let's put that in and then we'll round our answer to 4 decimal places. Once you enter that, you should get 1.8508. And that's it. It gives us an approximate value. If it does not specify, 4 decimal places is a pretty good amount of decimal places to keep. If it does specify to the nearest 10th or 100th, you can round appropriately. Let's do a couple more of these. Let's do cotangent. So cotangent is the reciprocal of tangent, so it will be 1 divided by tangent, 4.5. It is good habit to wrap that 4.5 in brackets if your calculator doesn't default to that. And we get 0.2156. Final one, cosecant. Notice there is a pi in this one. You might want to try and use the pi button on your calculator to get that answer as accurate as possible. So this will be 1 over a little bit of a bigger fraction, sine, bracket, 10 pi over 7. And this is where in a calculator, if you wanted the steps for entering it, I would do 1 divided by bracket, sine, bracket, 10 pi divided by 7, close your bracket, close your bracket. Depending on your calculator, this bracket may not be necessary, but there is the occasional calculator where you have to do this part of the division first and then press the sign button, and you will really need the second set of brackets there. Okay, and when we calculate this one to the nearest 4 decimal places, this will be negative 1.0257. Notice that this gave us a negative. That is okay. Think about where 10 pi over 7 lands and what quadrant it would be in. It's more than pi, so it's going to be in quadrant 3, where sine is negative and therefore cosecant is also negative. And that's how we find an approximate value. Pretty straightforward.